So let's take a look at set-driven keys. The concept here is I'm going to create a new document just to kind of experiment and demonstrate with this concept. But the notion of set-driven keys is that you can build you can build dependencies between objects and cause one object to affect another object. And I'll demonstrate this, and we'll take a deeper dive into it in a moment. Now, there are lots of different ways to build dependencies in Cinema 4D. This is a really robust environment for building character rigs or set rigs. You can do that with constraints, with set-driven keys, with inverse kinematics. It's a really rich topic. We're going to take a basic kind of surface look at this to help us out with the Exploded View project. We take a much deeper dive into this in the simulation class. So in order to get this demonstration set up, what I'm going to do is I'm going to take two different pieces of geometry. I'm going to create a cone, and I'm going to create a cube. And the idea here is I'm just going to kind of move that cube into the background just a bit. I'm going to use the cone as the driver for my animation. So in other words, I'm going to set a parameter on the cone so that when I move this cone, it's going to affect a parameter of the cube. Now, in really simple terms, I'll just establish this. In fact, it may be helpful. This might feel like kind of an abstract concept at first. It definitely takes a little bit of experimentation, and you're going to want to practice this a few times to get the concept down, so that you can transfer this knowledge to your Exploded View project. Of course, it's always best to experiment with just kind of a disposable file like the one that I have in front of me. What I'm going to do is I'm going to take the cone and I'm going to call this cone driver, just as a reminder that the cone is driving the animation. Now, the basic concept here, let's say that as I move this cone up along the y-axis, maybe I want to cause the cube to rotate along the y-axis. Okay, I can do this by establishing a driver and a driven relationship. Okay, now I'll demonstrate this, and of course I'll review this a couple of times, but here's in really simple terms, here's how you set this up. I'm going to grab the cone object, and I'm going to look at the coordinate tab in the attributes manager. Now, the concept here is that when I move this object along the y-axis here, okay, so as the y increases, I want to cause the rotation value, just as a kind of a random demo. I want to cause the rotation value of the heading to increase for the cube. So let me undo the position of the cone. As I move this up or down, I can see the y value changing, and so this is the thing that I want to set as the driver. And I can do that by right-clicking on the y value, so I can either control-click if I have a single button mouse, or I can right-click on the y value. And when I do that, I have a couple of options that pop up. And I want to point out that I'm right-clicking on the actual y component rather than this parameter bullet. So prior to this, we might have been used to control-clicking on this little bullet to animate it, or right-clicking here to choose animation. I want to make sure that I have the y component selected. Okay, so I'm just going to click one time to make sure it's selected. I'm going to right-click on it. I'm going to choose Animation. And from the Animation tab, you can see that there's an option to Set Driver. And I'll choose that. Now, I've just set the Y value as the driver for the animation. The next thing that I have to do is set something as the driven component. Okay, so I'm going to choose my cube. And as I mentioned, the thing that I want to affect is the rotation of the cube. And so if I just kind of play with the H value of the rotation, so remember, if I have an object selected and I go to the coordinates tab in the attributes manager, I have the P value, that's position, and each one of those have its own coordinate, it's X, Y, Z. I have a scale, so this is position, scale, and a rotation. Each one of those have their own sets of values. So in the rotation field, I have a heading value, which I can change, and that changes the heading of the object. I'll just zero that out. I have pitch, and I have bank. Okay. For the sake of the demo, it doesn't really matter which one I choose, but I'm going to choose the heading rotation. Okay, I want it to rotate on the y-axis. So now remember, the last thing that we actually did was we selected the cone, we chose the Y value, we right-clicked on it and said set it as the driver. The next thing I want to do is I want to right-click on the heading value of the cube, go to the animation menu, and I want to set this as driven. Now, there's two different choices for driver and driven. Chances are you're going to be better off, unless you have a compelling reason, to choose set driven relative. And I'll choose that. Okay? Now, don't run out of the room scared right now, because we will review this process and we'll talk about it in great detail. But right now, what I've just done, and I will review this process, what I've done is I've set up a relationship that if I select the cone and I move it along the y-axis, it increases the heading rotation as we move that. So I can just kind of move this around. Now, that might be kind of cool, but you might be saying, well, what does that do for me? Well, not only can we set up a relationship that causes one position to affect the parameter of another object, and keep in mind that I did apply that to the y-axis only, so that when I move it along the x or the z, it leaves the cube uninfluenced. We're going to apply this and leverage this relationship to our exploded view project, but before we do, let me take a closer look at this. We'll take a look at the implications for this in the next presentation.